Hello and welcome to What Does 3D Printing Have to Do with Glass with Norwood Viviano. My name is Ted Sawyer, and it's my pleasure to welcome people from all over the world to today's session. So to those of you in the Western Hemisphere, thank you for fitting us in what's likely the middle of your Saturday. To those of you in the UK, Europe, and Africa, thank you for staying up late with us. And for those of you across the dateline in Asia and Australia and New Zealand, thank you for waking up to be with us. We look forward to spending the next hour with you. And if we find that there's still good momentum and energy and ground to cover after the hour is up, we may go a little bit longer. If you have other places to be after 2 p.m. Pacific time, don't worry. We are recording this session, and we'll send a link to the recording of the session early next week. So during our first half an hour today, Norwood will take us on a tour of his artistic practice and talk about how he came to be the foremost practitioner of using 3D print technologies for kiln cast glass. In the second half an hour, we'll answer questions and address any comments that may have been submitted in the chat. I know that by now, most of us are very familiar with Zoom and online meetings, and I just wanted to quickly go over a couple of things before we get into our program. First of all, open up the chat window if you haven't already done so, and say hello and let us know where you're coming from. Then keep the chat window handy so that you can ask questions during the presentation. We'll do our best to get to your questions either directly in the chat or by voice when we get to the Q&A session. Everything that happens in the chat will be part of the recording. And if you'd like closed captions, just click on the CC icon at the bottom of your Zoom screen. Select English because that's the language we're presenting in, and the captions will turn on. You can turn them on and off anytime you like. And with those few little things out of the way, we're ready to meet our featured speaker, Norwood Viviano. I don't know how I had the good fortune of first meeting Norwood, but I do remember that when I saw his work, I really wanted him to come to Bullseye to teach a workshop. And fortunately, in 2016, he was willing to do so. I subsequently tried to get him to come back to teach again, but being in demand and having a full-time position as a professor and sculpture program coordinator at Grand Valley State University in Michigan had him stretched very thin. So recognizing that I'd never be able to get Norwood to teach as frequently as the students that we serve would like, I invited him to come and make a master class video on his area of expertise, 3D printing and kiln casting glass. So in 2019, we did that. Little did we know that within a year, this would become one of the only ways that people would be learning for a period of time. Norwood's work has been the subject of solo museum exhibitions at the Grand Rapids Art Museum and the Chrysler Museum of Art in Virginia. It's also been included in group exhibitions at the Museum of Fine Arts Boston and the Corning Museum of Glass and the De Young Museum and the Museum of Fine Arts Houston and a bunch of other museums. In other words, it's an incredible honor to have him here as part of our program. So without further ado, I give you Norwood Viviano.
Thank you, Ted. I just wanted to say a couple of things. The main thing is that I think Bullseye is like the perfect situation to discuss new technology and glass and thinking about the amazing educational tools that Bullseye has available, and combined with the innovation that that you see in terms of the products. This is a really cool opportunity to learn about the potential of kiln cast glass and 3D printing. Thank you. Before I get started, I wanted to thank Ted Sawyer, Kim Sharp, as well as the Bullseye Glass community, and thank you for being here. So in terms of my studio practice, a lot of it was formed from growing up in and around the city of Detroit. And so these are some of these images are things that I looked at or influenced my work. And so on the left is Michigan Theater, which was a theater at one time and is now a parking garage. On the right is Michigan Central Station, which was a hub for trains in the city of Detroit and closed more than 30 years ago. It's actually in the process of, it was just restored. So, it's sort of the pinnacle of the process of that Detroit's going through right now in terms of its restoration. I also lived in a small paper mill community called Plainwell, Michigan for 15 years. And so my work has been a lot about the relationship between industry and community. And so really understanding that relationship and the power dynamic within that relationship. So just before we moved to Plainwell as a family, the paper mill closed. And so many of the families around us were sort of dealing with the transformation of the community and the transformation of their jobs as people were leaving the community to find other opportunities. And this is the Plainwell Paper Mill on the Kalamazoo River. And the first project I'm going to talk about, and I will say I'm only really going to talk specifically about two projects today, is mining industries. And the project isn't really about the mining industry, it's more about the layers of the landscape and thinking about the impact of industry on the landscape or the transformation of industry that the industry has had on the landscape. And so within the project, you'll see different kinds of data sets that describe different kinds of time periods. This is the first project I'm going to show you within the mining industry series. It was a commission for the Speed Art Museum in Louisville, Kentucky. And the piece on the left in clear is downtown Louisville. The piece on the right is the Martiki coal mine or Martiki strip mine in Lovely, Kentucky. Below the kiln cast glass is actually a reflection of imagery from an earlier time period in both pieces. And so when I cast these pieces, I am very strategic, or I try to think very strategic about how I'm working with the glass. And so within the mold making and the molds, the investment molds that are going in the kiln, I'm very strategically stacking the glass to get kind of a reference to strata or layers of earth. And this is an example of the imagery that is reflected below the glass. And so you see the aerial photograph. The glass is a representation of a fairly current landscape. The imagery is about 40 years old. The drawings in pink and yellow are actually hand-drawn sand-borne maps. Most of those buildings are gone, and all of that area has been redeveloped. This is the Martiki. This is the Martiki strip mine. One of the things about the Martiki strip mine that I think is really interesting, and you can kind of see this in the aerial photographs on the left, they are representative. The one in green is from the 1950s, before the mine was in production. The one on the right in kind of a reddish brown hue or tone is from the 1980s when the mine was in peak production. And so the mine has been slowly tapering off production since the 1980s. And so to capture these landscapes, I have both flown LiDAR, which is light detecting and ranging technology, and I've also downloaded free files from the USGS website. And so this is essentially or very similar to the technology that's used on like the highway to track your speed. A laser is flown over a landscape, and it bounces laser beams back to the plane and captures that data. Each point has an X, Y, and Z coordinate. This is downtown Boston. A project like this could potentially have several million points. And at this point, it's really considered point cloud data. It doesn't exist as anything more than a series of points. And so I'm working here in GIS software, which is geospatial software, if you're familiar with it, like ArcGIS or similar. And so one of the things about this is when you fly a plane over a landscape, you can't capture the sides of buildings. You're just capturing the top of the building and the parallel plane of the landscape. And so the different colors here mean different elevations. To use this data, I have to then wrap the points or connect the dots into a three-dimensional model. And so, and in that way, you can kind of see, it almost looks like a Christo or a Jean-Claude landscape where, you know, you sort of throw a piece of cloth over the surface. But that's because the points, you know, the point at the top of the building doesn't always line up perfectly with the point at the bottom of the building. And so when you stitch those together, you get a little bit of this kind of draped or folded landscape. And so I couldn't output these without working with 3D printing. I started working with 3D printing in the kind of the mid to late 90s. And this is what 3D printers looked like then. And there are people who are still running these machines. They're just not as prevalent. So on the left, kind of the upper chamber is where the 3D printing was visible. And this process is different in that the print actually, as it's being built, it kind of disappears into that lower chamber. You could create fairly large objects with this. This was a liquid ultraviolet curing resin, similar to Formlabs machines now, except on a larger scale. So I'm going to talk about two projects in the mining industry series. This project was the second project was a commission for the Shanghai Museum of Glass. And so I was really interested in how dramatic this landscape is, but also the amount of transformation that this site has had over the last 30 plus years. So in the next image, you can see, you know, the image that's reflected below in the mirror, you can see here, and on the left is an image that really describes nothing like what you see to the right. It is an image that really describes a series of factories or industrial complexes. And then what you see on the right is a much more fantastical, but very, very close to what is there now. And what I will say is gathering data in China is a much more complex process than gathering data in the US. And that's a longer conversation. I don't really want to get into that today. But to create one of these projects, I'm just going to kind of go through the process of this. To create one of these projects, I start in Google Earth and I create a polygon, and that polygon can then be, because it's all a world coordinate system, that polygon can be applied to a point cloud data that's also in a world coordinate system, which is the LiDAR data. And then once I crop that data, I can engineer it in a way that it is 3D print ready. And so a lot of times in my studio, you know, when we talk about the masterclass video, one of the things about that video is that we're teaching people how to go from 3D prints directly to kiln casting. In my studio, if I'm working on a large scale like this is 18 by 20 inches, I am not in a position to melt this out of a investment mold. I have to do what I would do in case I need to make this again, which is to make a rubber mold, and there's a plaster mother mold around this, so the rubber is very thin but flexible, so it removes from the wax very easily. And so this is a kind of a rendition of the wax, an example of what was originally in um, as a 3D print, now has been transformed through the process of making the rubber mold and then casting in wax. To make my molds, I tend to work pretty traditionally. I work with Ransom and Randolph Glass Cast 910. I'll talk about that a little bit later in the video in this. But I want to, I want you to be aware of the fact that when I'm making molds, I'm really thinking about the thickness of the mold material because that impacts, how a mold heats up and then how a mold sheds heat as it's annealing. And so if I create an area that's too thick, not only am I wasting material, but I'm also causing potentially a failure because the glass can't cool at the same rate as another part of the mold because of the thickness. And so I also, with this material, I also don't tend to steam out my molds. I tend to melt out the wax from the mold in an oven. This mold material is very sensitive to steaming. You can erode the surface very easily. And so I do have a little bit of wax residue in the molds. I tend to fire my kilns at night and I have good ventilation, so it's really not an issue. And then one of the things that's always a challenge, the molds in the kiln, it's leveled, but stacking the glass, because the interior of this mold is not flat, but I have to figure out ways to get 75 pounds of glass in this mold. I really don't like charging molds at temperature. I will do it when it's necessary, but I tend to find that you can run into problems that way. So anyway, stacking the glass on essentially stilts, balancing 40 pounds of billet above the mold, ended in a pretty good result. This is the mold at 1550 degrees. I tend to soak my molds at 1550, anywhere between 6 and 12 hours, depending on the complexity of the patterns that I'm trying to capture. With these open face molds, it's a little bit more it's a little bit more flexible because I can see what's happening in the mold. In a closed mold that I can't really see what's happening, I would definitely go for a longer soak to make sure that the mold actually fills properly. And so this is the mold after it anneals for about 2.5, 3 weeks. And you can see that, the glass is, there's no spilling of glass over the mold, but also there's, there is some mold degradation or breakdown of the mold material, but not enough that would cause any either major casting flaws or problems with the mold, like letting the glass go during the firing. And so the second project I'm going to talk about today is recast. And this project incorporates the landscape, but it also incorporates the objects of industry. And so this is Recasting Detroit, the first piece in this series. I made this while working as a fellow at the Wheaton Arts and Cultural Center in Millville, New Jersey. And so I'm going to take you through a few steps of making this piece just to give you an idea of some of the process. It kind of builds on some of the last process I just showed you. But this piece was more challenging because it wasn't just a simple open face shape. And so this is how I work with a lot of the pieces in this series, and this series is very current in terms of being the project that I'm working on in my studio right now. And so I will graft the landscape onto an object. And so one of the things that I really like about these pieces is this sort of, here you can see this sort of pin piercing the water of Detroit. So the landscape is kind of affected by the object in some way. There's some that are affected in more dramatic ways. And so I make a mold, a rubber mold of this that's about 2/3 of this object, including the landscape. I don't make a mold of the whole object because I don't need the whole object. And in some ways, working with fragments of objects, I think, is more interesting. And so once I have a wax, it's a fairly direct process to work through all of the steps that I showed before. A lot of people ask me how long does it take to make a piece. I usually say between 80 and 200 hours, depending on the nature of the complexity of the shapes. And if it doesn't work the first time, then I have to go back, not necessarily to the drawing board, but I have to go back and start with wax working from my rubber molds. And so, again, Wheaton is a place where I didn't really have access to a wood shop, so I had to improvise. And you can see the foam here, sort of where it will displace the plaster. That way I can end up with a fairly even mold or reasonably even mold. I find with these molds, chicken wire works great. I'll talk about that again in a little bit related to some student work I'm going to show you. And then the mold in the kiln, I shaved off some of those shapes on the front just to kind of even out the mold. This is about 70, in the end, it's about 75 pounds of the juniper, bullseye juniper green. And it takes about 6 hours to kind of all be charged into the mold. And then this mold was in the kiln for about 3 months to anneal because of the complexity of the shape. And it was about 9 inches thick. And, you know, to not get into a larger discussion of annealing, I have found that I have to extend my annealing cycles out if I'm working with these really complex shapes with this mold material. And then one of the benefits of the mold material that I use is I can soak my forms and get the mold material off really delicate shapes. It also keeps the dust down, so there's some like added health and safety benefits to it as well. But I don't think there's a way to get the traditional plaster investment off these delicate shapes without breaking some of them. And I just wanted to say that when I exhibit these projects, I'm typically exhibiting, you know, these are kind of pedestal pieces, I suppose, but alongside of them, I'm always showing something that references an earlier time period or relates to the object in some way. So, on the right is an aerial photograph that's been cropped in the way that the landscape has been cropped and is connected or grafted onto the object. And this is just a side view. And again, you can kind of see the protrusion of the pin in the water of Detroit. And I think that those are kind of interesting moments in terms of the relationship of the landscape or the object's relationship to the landscape and the industry. And you can't really have a discussion of Detroit without having a discussion or thinking about the relationship of Houston. It's a sort of a symbiotic relationship between Houston and Detroit. And one of the things that was really, you know, if you can think of mold making as fun, you know, there's this, the hole that you use for filling or draining the drum kind of pierces the landscape in a really dramatic way on this piece. And I actually had to remove a sports stadium to be able to get it to kind of fit that object. And so in some ways, the object becomes a stand-in for the landscape or vice versa. They kind of work together. And then the last piece in this series I'm going to talk about is recasting Portland. And since we are, you know, this is a Bullseye Glass sponsored event, it seems like here's an opportunity to engage directly with Portland. And so this was originally a Douglas fir tree that had been cut down, and I 3D scanned the lower portion of it and took the scan, and you can see the sides look like bark. I took that scan and I actually grafted the LiDAR onto that scan, and I could scale and shape, and then I could actually cut, you know, in the computer, I could cut the scan data of the tree with the LiDAR to make them really a seamless kind of coexisting, to have a seamless coexisting relationship. And the last part of what I want to talk about is related to um, the master class video, and but I'm not going to really show so much of the masterclass video. I'm going to show how some of these techniques developed, and with teaching workshops at Bullseye, with teaching workshops at Corning and other places, that's been really instrumental in kind of developing a language with new technology kind of embedded with more traditional kiln casting. And so I'm fortunate to work with really awesome students and have awesome teaching assistants while I'm doing these workshops. And so I start workshops by 3D scanning. Rather than throwing people into 3D modeling, which tends to slow people down dramatically, the first thing we do is 3D scan. So Hannah Knoll here is actually scanning the person sitting in the chair, and we're kind of working together. It takes about 3 minutes to scan each person, and then the scan software does all the cleaning, it does all the editing, and then on the right you can sort of see a collection of people that have been 3D scanned, and they're getting ready and prepped for 3D printing. And here's some examples from the class I just taught, workshop I just taught, that have been cast in glass. And so the process is to 3D scan, then 3D print, and these are printed at about 3 inches tall, and then invest those in a plaster investment, melt out that plaster investment, and then flip the mold over, put the glass in, and fire it like a traditional firing. Although you can go a little faster because you've already fired the molds up to about 500 degrees. And the student in the background is actually the student with the red ruby here in the middle. So that's kind of a nice connection. Other thing I was going to add, there's kind of a nice simple demo of 3D modeling software in the masterclass video, and this is actually the object that's modeled, but I just wanted to say that Rhino is a really great software in a lot of ways because it's the industry standard for architecture, industry standard for several other fields, but a lot of architects, designers, jewelry and metalsmiths, sculptors use it. But one of the things that I really like about it is that its workflow really is directed towards output. So most things that you make in Rhino can be 3D printed. And I think that, as an artist who works with objects, that's a really essential tool. And so on the left is a 3D print that's about halfway done in printing. And you'll notice that we work with clear PLA, or you might notice this. We tend to work with clear PLA because the tinted color PLA sometimes leave residue inside the molds, and then stick to the glass when we melt the mold material, the PLA out. On the right is just an example. I have no sponsorship. I get nothing by sharing this with you, but Hatchbox PLA is usually considered pretty good PLA for the price. You could probably, for example, the project that I just showed you of the little heads, busts, you could probably make about 30 of those with this one spool. So it can go a long way, especially if you're working small. But this clear PLA is what I would encourage people to kind of think about if you're starting to work with this technology, because it eliminates some of the problems that people run into with, materials on the surface of their glass. So this is, on the left is the 3D printer that's running, and on the right is the slicing software with this 3D print set up. And so you're not going to really see a lot of building happening on this print. It's probably a 6 or 8 hour print, and there's about 75 to 100 layers just in this print. And so you're not going to see much in a 20-second clip, but the idea is that, basically it's a really fancy hot glue gun that's really dialed in to essentially build these objects consistently and pretty seamlessly. The other thing I will say about this PLA material that's on this printer is that it is biodegradable. It's a corn-based plastic. It's very easy to evacuate from investment plaster molds. And so for plaster mold making, for this process, what I use in my own work is Ransom and Randolph Glass Cast 910. It works really, really well if you follow the directions. It also gives you very consistent results. It's very high quality material. If you're on the West Coast, there's distributors that sell it also on the West Coast, because shipping is almost as expensive as the material itself. And so I, again, work traditionally, or with my classes, I teach pretty traditionally. Once we get past the digital technology, and so the image on the left is actually a PLA print, and the chicken wire is to reinforce the mold, because we are going to go through a twice fire process. So that chicken wire really makes a dramatic difference. And then the image on the right is just pouring that mold. And then I did mention this earlier, but to evacuate the PLA, you have to put the molds in the kiln, and it's almost a 24-hour cycle depending on the thickness of the molds. But you can melt the PLA out of the molds. You don't need to burn it out of the molds. And you can capture the PLA in trays like this with aluminum foil. And then when the PLA is melted out, the molds have cooled, you can take those trays out, get rid of the aluminum foil, and flip the molds over and fire them like a regular traditional kiln cast mold. And here's just some examples of things that, the students were making in my most recent workshop. The piece on the left, the clear piece, is actually an interlocking project that the student designed, and then had a inclusion of like an ellipse sphere, squashed sphere inside. And for the most part, other than some cold working, it fit together really well. The thing about 3D printing is that you can get a certain level of accuracy to the process. If you need to make, 3 parts the same, but one, or nearly the same, and one is a different size, it's very easy to resize things within the tools that you have available within this process. And then the last thing I wanted to talk about, and I've always loved this image. This is Susan Edgerly, who's a really incredible Canadian artist, but I worked with her in a workshop, or I had the opportunity to work with her in a workshop, Espace Vert, in Montreal. And in the foreground is a 3D printed object that she made in Rhino. On her computer screen is a rendering of that object as glass. And so I'm not sure that this necessarily informs the conversation of what is happening in glass related to 3D printing, but I think it informs how this technology can help us show people our ideas, or work through some kinds of ideas and problem solving without having to necessarily go through all the steps of making a final piece. So I think that this speaks really well to that. And that's it. And thank you very much.
All right, everybody. We're ready to start answering questions in earnest. But before we do, I'm going to encourage everyone to raise their hands and wiggle their fingers in thanks and appreciation and applause for Norwood. Uh,
Thank
that
you.
was great. Yeah, it was really wonderful to learn more about how you developed this working method and what you've done with it. It seems like it was such a logical and natural progression for you. Was it?
I think that, you know, it developed over the course of teaching workshops. I think in my studio, I take less risks than I do when I teach workshops. And I want to just say that, you know, if people are interested in this, the best way to do it is to start small and then to work your way up to larger projects. In fact, my teaching assistant, John Reese, has been a TA for me at several workshops. He's doing some very large pieces, architectural pieces with this process. But I think the reason why he's having like really nice, beautiful castings out of this process is that he worked his way up to that. So workshops are a really awesome way to kind of experiment and learn. And then, you know, it always informs what I do in my studio. You know, to have that many people experimenting at once and trying to kind of understand what that experimentation means in such a short amount of time is a really awesome tool. And I think I said this in the video, but I've been working with 3D printing for about 25 years. And just in the last, you know, 5 years, I haven't really, every time I talked about 3D printing, I didn't have to explain what it was. So I didn't always know when I first learned how to 3D print or when I got interested in the process, I didn't always know what I would want to do with it. And it's just really in the last 10 years that the technology has synced up to a point that it's affordable. And the ideas that I'm working with in my studio kind of align with the process.
What advantages do you see in this method of working for someone who doesn't necessarily have sculptural training, or are there any?
I think that there's a lot of advantages. One is if you are needing to work on a certain scale, like say for a proposal, and then you need to scale something up, this technology works really effectively at scaling. Also, if you need to have very consistent dimensional accuracy, or you want pieces to fit together. One of the projects that I often teach in my workshops is the project that I showed just a few minutes ago, an interlocking project where you have 3 or 4 parts and they all need to fit together. And with glass, you can take advantage of color and density and there would be no other way to do a project like that without using the tools within the software where you can actually subtract one object from another, getting almost a perfect example, like of taking getting a 3-dimensional fingerprint of an object. And so and I use that because then you can kind of learn through all of the steps, like how much does your mold material expand, how much is your wax, or how much is your glass shrinking in the process, how much cold working do you need to do. So there's a lot of ways to kind of capitalize on that process.
Yeah. And I think a lot of people here are probably wondering how difficult it is to learn to use the software and the printers involved in this process. Is it fairly straightforward, and are there resources that are readily available for learning? And just one more, if you don't have a 3D printer and you don't want to get one, what are your options?
So I'll start with your last one first, and if I can remember all of the questions, I may come back and ask. If you don't have a 3D printer, I think the first thing I would do, and a lot of public libraries now have little maker spaces, and in fact, I've taught workshops I have three working 3D printers that I use for teaching as well as some of my own work. but I also don't always use my printers, the printers I have that are for teaching for my own work because my students are using them. But almost every public library has some kind of makerspace. And so it should allow you some freedom and low impact in terms of like financial commitment to start there. And so I also say to people, like, if you're thinking about buying a 3D printer, think about the cost. So, obviously you can still spend $30,000 or $40,000 on a 3D printer. You can spend $150 on a 3D printer. I probably wouldn't spend $150 on a 3D printer if I didn't like to tinker all the time. But for $500-600, you can end up with, I've been recommending Prusa printers to a lot of people. Prussa. I don't have any affiliation with them. I just hear lots of positive things from people, and I've seen many prints off of these machines for $700. You still have to build it, but it's a pretty simple and straightforward process. So, and then there's online service bureaus like iMaterialize and Shapeways, and some of these online service bureaus don't produce parts in PLA. They may produce parts in other materials. PLA is a very easy material to melt out. The other materials would require a burnout, which is burning plastic out, which I would not recommend doing. I would not do that in my own personal studio, and I would not recommend anybody here do it. But the PLA, you melt out, get it out of the kiln, you pull that aluminum foil out, you get it out of the kiln, and then you can flip your mold over. You only maybe have 2 or 3% of the PLA left. You load your reservoir with your glass, and you just fire the way you would fire normally. And I mentioned that you can fire, I think, a little quicker because your mold has already been fired once. So, you can, it's pretty dry already. So you're not starting from a mold that's just been made and is essentially 1/3 water.
All right. So you've mentioned melting out the PLA a number of times now, and I just want to clarify that's not a steam out process. It involves no water, and you're doing that at about what temperature?
I started a lot of my earlier kind of explanations of this process were around 450 degrees. The PLA comes out of the extruder of the 3D printer at 215 degrees Celsius. And I apologize for making people think about two different ways, two different systems here. But my software I use is going to be in the metric system, and my kilns are not in the metric system. So I'm always thinking about things in two different systems. So the extruders extrude the PLA at 215 degrees Celsius, which I think is 430 degrees Fahrenheit, approximately, somewhere in there. So I have done my meltouts at 450 degrees, but for my more recent studies, projects, I've been bringing that temperature up to 500 degrees, which speeds up the process a little bit. But the thing you want to think about is you're not going to put a mold in the kiln and send it up to 500 degrees immediately, because I think we all know what happens to plaster when you do that. No matter how strong or robust the material is, it's going to crack. You're asking the plaster to evacuate the water too quickly. So for a small mold like 6 inches, 8 inches by 8 inches by 8 inches, I might go up to 500 degrees over the course of 10 hours, and I might hold at 500 degrees for between 8 and 10 hours. I believe I mentioned that it's almost a 24-hour process. You could probably make it faster, but I typically, as somebody who's been kiln casting now for, I guess, a long time, I have just decided that kiln casting takes a certain amount of time. And every time I try to rush that time period, it usually comes back in a negative way. Like I think we all know what happens when we rush the annealing cycle. But if we rush our molds, we get cracks and flashing and things like that.
All right. And so just a bigger question, what tools and machines are needed if someone's going to get this video? If someone goes and purchases this video from Bullseye Videos, what will they need to actually realize the project?
So I didn't answer your question about software. So that's probably a
Yeah.
good one to answer. And I would also say that, if you want to start with 3D scanning, most phones now have LiDAR on them or some kind of 3D scanning, or you could download like a photogrammetry app. I had a student in a recent workshop that said, I don't really want to learn Rhino. I'm going to teach myself photogrammetry. And they were able to take these objects, take photographs of them, upload the photographs, and then turn those photographs, the online system would turn those into a 3D model from the photographs. Of course, you have to be really good about and very systematic about how you take the photographs, but the photographs can become a 3D model. And I've been doing a little bit of photogrammetry in my work for projects where I take Google Earth imagery and then turning those into 3D models. And that's been a much less expensive way than trying to fly my own LiDAR for projects, but it's available at home. So that's one way to start kind of thinking about how you would build something and get it into the computer and then potentially get it out of the computer or turn it into some kind of other scale or whatever. The other is, if Rhino is intimidating in any way, and I will say that, 25 years ago, none of these processes, I mean, there are very few people to talk to outside of engineering. There were very few people that really understood or knew these things. And so as much as I'm interested in engineering and understand some of the theoretical information around engineering, I am not a mathematician or anything like that. I like Rhino because it's intuitive, or like at least I find it to be intuitive. But I would say that if Rhino isn't the right software, there's Fusion 360, which is an equivalent of Rhino. It doesn't work as well for the work I want to do or the work that I teach, or Tinkercad. Tinkercad is a very simple, direct software to learn, and it will give you some insight into the possibilities. You may run out of what you can do with it after, a project or two, but it gives you, again, a sort of a taste of what the software can do. Rhino is a free downloadable software for 90 days, and then if you want it forever, you do have to pay for it. So Tinkercad is free, Fusion 360 is free. So again, I will say that no software or no 3D printer will do everything you could imagine. So, like I use a bunch of different tools for the work I do, depending on the project I'm working on.
So that brings up the issue of slicers right away. And we have somebody asking about that. And I know that you use Cura as a slicing software quite frequently. Can you just really quickly, without teaching a whole class here, walk us through sort of the chain of events, Rhino to X to Y
Sure.
to
Sure.
Z?
I'll keep it to 3 minutes or less. So you make your object in Rhino, you scan your object, whatever it is. Usually the file format that goes to the next step is an STL file. So it has a STL file extension, which means it's a triangulated mesh, usually with nothing inside. It's usually, meaning you're not going to make a triangulated mesh with two parts that overlap, because 3D printers don't know what to do with that. There are ways to kind of get around that, but for the most part, they don't like that. And so you're going to take that STL file and you're going to import it into, as Ted mentioned, a slicing software. And so the slicing software, and I will just say, if you're going to work with a slicing software, Cura is probably the easiest one to start with. I use Cura a lot. I've only been in a situation once or twice where I couldn't get Cura to actually slice what I needed to slice, and I had to go to a more robust software. So you bring your file into the software. It has a few settings. So you'll notice, you might have noticed a little bit, we didn't show a lot of 3D printing like this, but like with the heads that I showed, the busts, you know, as your chin kind of cantilevers out over your body, the slicing software will actually automatically build supports in there to help the printer print those areas which are cantilevered over the body. And so it does two things. It will create a raft around your part, which helps hold your part down to the bed of the machine as it's printing, and it will create supports. All of this stuff is customizable. I always advise people to start small and then to learn about how to customize these things as you have done, you know, after you've done like 10 prints, then go in and kind of begin to customize and see what some of those tools will do. Because you're not going to appreciate what they do until you actually have enough information to engage with all of those small things that you're changing within the software. But generally, the slicing softwares are free, open source softwares, or they come with the printers. Cura is an Ultimaker product, but is also applicable to many, many, many 3D printers. And so I really like that. I use the MakerBot slicer for MakerBots. Each one of them has the sort of their drawbacks. There are professional grade slicers where you can really customize all of the information that you're doing. You can go in and remove supports. You can, you know, set the angle of supports, which you can in Cura. But again, as long as I've been doing this, I rarely need to do a lot of customizing to things, because I think, again, you know, I'm not doing super complex work either.
Right. And so you've got your Rhino file, you brought it to Cura, then from Cura, you've sliced it, you send it to the printer,
Yeah.
you print. Now you have a print, and you can either take a mold of that uh, and then make multiple waxes from that mold, or you can invest that directly in some sort of casting material. So that's basically, those are the basic steps there. What could you comment briefly on the difference between plaster silica 50/50 and the Ransom and Randolph product? Because you mentioned being able to soak your cast piece inside the investment and just have the investment melt away. What would happen if you just soaked your plaster silica castings in water?
Well, I haven't actually used plaster silica in a long time, so I would hate to say this for certain. But my experience was a long time ago that it expands enough to crack the work. And so I think it again may depend on how thick the glass is, but my work is usually a large, thick object with these very fragile appendages attached to it. So I need to have mold integrity, because usually I'm casting in a certain direction. I need to flip that mold over to soak it. I usually put the glass side down, put foam in a soaking tray, flip the mold over so the glass is sitting on that foam, soak it overnight. Every once in a while, Ted would probably have a better answer for this, but every once in a while, I'll soak it overnight. I'll come in and there's almost no mold material left on my project. Sometimes I'll come in and I think I make my molds with the same formula every time, but again, I might not because I'm not scientific in a laboratory environment. And then sometimes I come in and the mold material is a little more has a little more integrity, and I have to go in. I use never use metal tools when I'm devesting something. I always use wood tools because I can chip the glass or knock buildings off, edit the landscape, as I would say. And I often just use bamboo skewers, but it can crack the glass. The Ransman Randolph 910 has, plaster of silica, grog, kaolin, flint, all kind of embedded in the dry mix. And so it's also very well tested. So what I appreciate about it is I'm getting the best materials. And so when I'm making a project, I could have 30 hours or 40 hours in a wax. And so if I'm using the 910, I get the results as close to what I would want as possible. But in the process that we're talking about, I think it's really critical because it has a lot of mold integrity. So if you are doing this twice fire process where you're putting an investment mold in the kiln with PLA plastic and melting it out, you're bringing that mold up to 550 degrees. And then likely it's coming almost down to room temperature. And then you're flipping it over and then bringing it back up to 1550 for casting. And so that's a lot of mold trauma, a lot of heating and cooling. And I find that the 910 does a really nice job of kind of surviving that process with very little impact. I'm sure if you could get to a point where you really dial in a plaster silica mix to do the same things, but my experience is with plaster silica, you get a lot more fissures, a lot more flashing, and just mold movement through those steps.
Norwood, could you clarify, do you melt your wax out of your 910 or do you steam it out?
I do both. If I'm working in my studio, I will melt it out. If I'm working like doing a residency at, like at Wheaton Arts, I just did some firings there recently. I always take my molds from my studio with the wax in them. I think they're safer to move molds that way. And I will, for a large piece, I would put like 3 or 4 steamers in. My philosophy has been the faster the evacuation of the wax, the better. And the longer the steamers stay in there and kind of bubble, the more degradation you have of the mold material. And the last one I steamed, there was no surface degradation at all, which, honestly surprised me. But again, I think because I worked, in a half an hour, I was able to steam out a very large piece. But it again, the only times I've really had problems is when the steamer just sits there for, hours inside of a large mold. It just kind of starts to erode the surface. And as I mentioned, there's, kaolin, silica, grog, all of these things in this material. When you oversteam it, then that's when you get, you kind of, you sort of scrape away that plaster rich surface, and those things will stick to the glass. But it's a pretty rare occurrence, but it's one of those things when I'm teaching, a lot of people will say, why am I getting this on my glass? One is when you're pouring the material, read the directions. It tells you how long you're supposed to mix it and when you're supposed to pour it. And if you pour it way too soon, you mix it for 2 minutes and you pour it, those things have those materials that like to stick to the glass fall and settle onto the surface of your wax or your PLA print, and then they end up sticking to your glass. But if you pour it when it's got the correct mixture, which is about 8 or 9 minutes, then the density is correct. You've really kicked off the plaster in there. It's like plaster silica. Plaster silica is not as strong of a mold mix as a straight plaster mold, but you're never going to put a straight plaster mold in the kiln. So you're making a mold that has a whole bunch of other things in there, and a lot less plaster.
Yeah. So the issue, just to clarify, when you steam out one of these R&R molds, that you risk degrading that sort of perfect face coat that forms when you've mixed that material properly. That's right against the investment. And as soon as you steam too aggressively, you start removing that surface. So you mentioned that you will also melt it out sometimes. Could you tell us the temperature that you'd do that at, and why you would choose it, and what might counter indicate doing that?
Well, I I think there's a well, the molds are large, so usually my molds are 150 to 200 pounds of plaster investment, and so I can put the molds in the kiln, and I can put them at about 200 degrees overnight. I usually let large molds sit 24 hours after I make them. And then I put them in the melt out oven, which is an old heat treating oven, uh, overnight for 200 degrees. And then when I come in the next morning, I slowly turn it up to about 325. And that's really over the course of maybe 4 or 5 hours. And then after 4 or 5 hours, I have a dry mold. So I'm not putting a wet mold in my kiln. And I have a mold that the wax is evacuated. So I have kilns that I've been firing for 10 years, hundreds and hundreds and hundreds of firings, and I haven't had issues with elements because I'm steaming out molds in my kilns, which is also a plus as well. The thing I would add, though, the drier the mold is and the more there's wax, the more wax that's in there, you're going to get wax that kind of seeps into the porosity of that mold. So you want to be careful. I usually try to go a little, once I've had the mold at 200 degrees, then I kind of step it up a little bit faster, and I don't get very much. And when I'm dealing with, when I'm firing the molds, the glass is in the mold, there's a little bit of wax residue in there. I have never had a problem with having wax cause carbon on the glass in any way. When I'm firing, I will also, whether I steam my molds out or not, I always do a 1,000-degree hold for 3 or 4 hours. That way I know that there's nothing left in my mold. And I'm always trying to go, to try to equalize the temperature of the mold before I go really high, because I find that the more equalized that temperature is, the better the firing is. And again, if you're working on a small scale, you can get away with a lot of stuff. When you start scaling things up, every step could have some larger impact on a project. And Ted knows from doing large scale projects, it's like when something goes wrong, or it can be something within one little step where you just made a split-second decision, and that can impact a whole project, whether it causes a tremendous amount of cold working or you start over. So I tend to be really careful and dialed in as I'm working on my work.
All right, good. Thank you for answering that question. We've got some real in the weeds questions that we might take. We're also just past 2 o'clock. Norwood, do you have a few more minutes to keep
Sure.
going? Great. Here comes in the weeds question number one. How do you convert topographic point cloud data into an STL file format?
Well, it's a semi-complicated process that takes ArcGIS software. So, you work from a LAS file which is the file extension for the LiDAR, and most LiDAR can be downloaded from the USGS website as a .las file, and then you convert it to a TIN file, .tin file, and then you can convert it to an STL file. So if you're working on really small areas, it's not a problem. But if you're trying to, say, work on several city blocks in New York City, you could have 6 million points of LiDAR data in in your file, and it could be, and think about the LiDAR data as just XYZ coordinates. Like imagine a Word file that's like 300 megabytes that goes on for thousands and thousands and thousands of pages, so when you get up to several hundred megabytes, you really need what I would call a reverse engineering software. So there's reverse engineering softwares like Magix, made by Materialize, or Geomagic software, which was made by Raindrop. Either one of those softwares would allow you to engineer a complex 3D scan. And maybe the easier way to explain this is that those softwares are often used for the tool and die industry. So to take something that's been, agreed upon as a design and then figure out the tooling for how it's going to be made, that can be used as well. So when I'm working on a project, I'm sometimes working with engineers, but if I was doing, some small LiDAR scan data, there's several tutorials online about how to take LiDAR from the USGS website. And I believe there's the LiDAR of the moon now. I haven't used it, but I've had some students that have inquired and asked about it. I just thought that's kind of cool. But there's several tutorials that take you through the steps that you don't need to have the GIS software for, and things like that. And I don't have GIS software. I teach at Grand Valley State, as Ted mentioned earlier in the talk, and there's a GIS lab that I can get access to. And usually when I'm working on a project, I just go in there and do the work. But I will say that, like anybody here, it's so hard to keep up with the software. So like sometimes I won't use it for 3 months, and then I go back to it and it takes me like 4 hours to do something that should really take 15 minutes.
All right. And let me see. What about, so you mentioned melting out the PLA. Is it something that you can reuse, or is it thrown away? And have you done anything with water soluble PLA?
The PVA or PVB. I know some people that have been experimenting with it. I think the problem is it's water soluble. So imagine making a large 3D print with this material and having it on the West Coast, which, may not be really wet now, but it's a water sensitive material. So the idea would be that you have a water soluble material that would steam out like wax. I don't think we're quite there yet. I think that there's some potential there for doing it, but especially if on a larger scale, I think we're still fighting some of the technology. Part of it is that the material that doesn't steam out sometimes leaves a more of a residue in the mold, more ash in the mold, and so than the PLA. The PLA actually leaves very little residue. And in fact, I have, in a pinch, and I'll tell you this, but I don't want anybody to do it. I have, with small molds, just burned out the PLA with my glass in a flower pot above it and just did my firing that way. Causes more fumes. So, I did it over a weekend where nobody was in the studio. And I was able to just sort of eliminate the melt out process and just fired it that way. So, and again, very, very little, if any, reference to the PLA ash or anything like that in that way either. But my recommendation would be to melt it out. And I know this came up a lot in my last workshop, like the distinction between melting out and burning it out. And so when I taught at Pilchuck at the time, we were being asked, this is back in 2015, we were being asked to burn it out, and that would be taking it past 800 or 900 degrees. But then imagine burning it out, what we were doing then, burning it out, bringing the mold back down to room temperature, and then bringing the mold back up to room temperature with glass in it. We were having a lot more cracking of the mold material and things like that. 500 degrees seems like a sweet spot where you don't have a lot of, lose a lot of mold integrity, and it doesn't take that much time. It will add a day to your schedule, your firing schedule.
That's great. There are two more questions that I think we're going to want to give attention to. One of them's, I hope, a short answer and very technical, and the other one's a little more personal. So this question is, what do you think of 3MF as a slicing software versus Cura? Do you know 3MF?
Not very well. So whoever's asking the question maybe could tell me a little bit more about it.
They're actually not here. They sent it in advance. I
Okay.
think there's somebody who's just getting started and is just trying to understand which is which. And what I heard you say earlier, it suggests to me that really Cura is going to be the best place for someone to start. But
Well, Cura is free, so that's a big plus. Or there's some open source version of Cura. So what I would do is, and there's also, because it's free, there's an incredible amount of online tutorials to use it. And Ted and I have talked about this before. There's just a lot of resources for 3D printing right now. There's also a lot of resources for learning the software right now. And I, you know, I don't think, how do I say this without, learning the software is not easy. Learning how to do basic things in the software is not hard. Making a commitment to learning it, or you can take an online workshop to learn it. There's a lot of ways to do it, and I mentioned before that there are other softwares that are really simple that will get you started, and it isn't a waste of time to start with a simpler software, because a lot of the tools do the same things in a software like Rhino that they do in Tinkercad. It's just that those tools in Rhino are going to allow you to do many more things. And so I don't teach workshops. I mean, I teach where I teach full time. I teach every semester. I teach a 15-week Rhino class. It's not a glass casting class. It is a Rhino class. We do output. We do laser cutting. We do all of that stuff. If I taught I don't teach Tinkercad, because we would run out of we would be running up against its abilities in 3 or 4 weeks. But I think it's a really great place to start, and it's very easy to transition from that to something else, and build on it. And like everything we do in our studios, it's like every piece, you can't see the future, but every piece is building on, like every new piece is building on the last piece that you did, or every new piece is building on the last piece of kind of technology and research that you just finished.
all right, brilliant. So here's the last question. It's the one that I said was a little more personal. Why did you settle on glass as the medium for these works? And do you think that your ideas are best realized in glass?
That's a great question. I think about material as metaphor. I've worked in a lot of other materials. If you happen to look at my website, you'll see that, for the last 10, 12 years, I've primarily been working in glass. I will say one of the things that I love about working in glass is the community. Not just the community we have here, but the sort of extended community. It is a very generous community in terms of sharing information. I have never emailed somebody and asked a question and had them say, no, I can't share that with you. It's always been, much longer than I expected, much more thorough than I've expected. And when I get those questions from people, I try to share as well. So I feel like there's a very reciprocal, sharing, generous. That doesn't necessarily, that's not necessarily a reason why I make my work, but I have felt like the work is about describing our relationship to the landscape and sort of our fragile balance in that relationship. And so glass has felt like the right material to talk about fragility. And and I do have ideas for other materials, even for some of the work that I've made up to this point. I've had ideas, I just really haven't had the time to kind of dive into those works. And I will say that I came to glass casting from metal casting. So I've been metal casting for about 20 years, and I still teach metal casting every semester. Um, but I came to it. And so a lot of my technical knowledge has been trying to apply what I learned related to metal casting to glass. Well, that doesn't always work, but there have been a lot of things in there that have helped me figure out aspects of glass casting that I hadn't. And one of them was in terms of foundry work, metal foundry work, the digital processes have been embedded in metal casting for much longer than they've been embedded in glass casting. So all of the fine art foundries that are left in America, and they're not many, but the few have digital divisions. And so, you know, those areas have really pushed the possibilities of what has happened in the field of metal casting, and I think now influencing what's happening in glass casting.
Norwood, we're now a little bit over, actually almost 15 minutes over. Are there any final thoughts you'd like to leave everybody with?
I think that it can be really intimidating to try something new. I think there's a lot of possibilities within this process. And the way that I always teach, you know, workshops is that I'm not interested in teaching people how to make my work. I'm interested in teaching people how to find their work within this process. So it's important to not think, oh, I need to make something that looks like whatever he makes, but think about what, if you're interested in this process, think about how the things that you make can work within this process. Does it make your process more efficient? Does it allow you, like, one of the things that I love about this process is when flying on a plane, I can be working on a Rhino file or something like that. So I'm rarely, you know, I'm rarely away from my studio when I'm physically away from my studio. So Rhino allows me to share ideas with a whole host of people, fabricators, and people that I work with on projects sometimes. That's become bigger, broader ways of thinking about the software than I originally imagined. So, you know, what I'll say is the things that are included in the masterclass video or the things that we talked about today are just scratching the surface. And I think that, you know, anybody here could be, you know, helping to build on this knowledge and information in the future, which I think is super cool. And again, going back to what I said just a few minutes ago, you know, we are here to, like, learn from each other and share information. So that kind of philosophy moving forward means that we all learn from the things that, you know, we're all learning from each other as we're working.
All right. Wow. Well, thank you, Norwood. That was really amazing. Thanks for your generosity in sharing all of that hard-earned information that you have, for your openness to the questions. Thanks to everyone else also for asking all of those questions. They were really compelling. I want to say a big thanks to Kim Sharp for making everything run so smoothly. I want to say one more time that we are recording this session, and we'll send you a link to the recording early next week. It will include everything that occurred in the chat. And yeah, you'll have that for 10 days. And of course, you can and should look at the masterclass video online, and go ahead and get it if you want to know more, because it's an incredible resource. So finally, thank you all for coming to this talk, asking questions, and providing your insights. We hope to see you again soon.
Thank you.